This GitHub page might hold the biggest pile of new mathematics anyone has published this decade. 10 problems, some open for over 60 years, and OpenAI says an unreleased model called Astra solved every one of them for about $2,000 in computing. Each proof ships with a certificate a machine can check line by line, and the machine finds nothing wrong. Then one mathematician read the fine print and said the boldest proof in here answers the wrong question.
The release is 3 things: a manuscript, 249 pages covering all 10 results, a companion document where the model narrates how it found the arguments, and the repository, where every proof is rewritten in a language called Lean, a system where a proof either compiles or it does not. No trust me, no details left to the reader. The repository's own manifest declares 0 gaps across all 10 certificates. Take the flashiest result. How tightly can equal spheres pack in a space with thousands of dimensions? That question controls how much information survives a noisy channel, and the best general answer had not moved since 1978. Astra pushed the governing exponent from 0.599 to 0.6044. Microscopic, except it sits in an exponent, so the gap between the old ceiling and the new one compounds with every added dimension. The proof also shows the method behind it can never do better. A 48-year-old wall moved, then closed.
Another chapter answers a yes or no question from 1999. Is there any infinite group, any system of symmetries, that can never be imitated by shuffling a large enough finite deck? For 26 years, every group anyone tested could be imitated. Astra built one that cannot. If it survives review, that is not a sharper number. That is a new kind of mathematical object. Why all the ceremony with certificates? Because OpenAI got burned in public. Last October, an OpenAI executive posted that GPT-5 had found solutions to 10 unsolved Erdos problems. The mathematician who curates that problem list checked. Most of the solutions were already in the literature. The model had done a brilliant library search. The post came down. That is how an AI math claim dies at level 1. The claim was never what it sounded like. The Lean certificates are built to kill that failure mode. Here is what the language actually feels like. Math educator MathPom proving a simple theorem on camera. Every step has to satisfy the compiler, and a single unjustified move stops the build cold. All 10 Astra proofs compile with 0 placeholders. OpenAI even ships configurations so anyone can rerun the check through a second independent verifier. Inside the statements as written, there is no room left for doubt. But notice the loophole. The compiler certifies the proof of the statement someone typed in. It cannot certify that the typed statement is the question mathematicians were actually asking. And that is exactly where the fight started. The boldest headline in the bundle claims a disproof of Kahn's rigidity conjecture, a decades-old question from Alain, one of the most decorated mathematicians alive, about whether certain infinite groups are uniquely fingerprinted by the algebra they generate. Within days, mathematician and philosophy researcher Jenny Lorraine Nielsen posted a rebuttal with a sharp charge. The groups inside the proof, she argues, fail the conjecture's entry conditions. If she is right, the certificate compiles perfectly and proves something about objects the conjecture was never about. The counterattack came just as fast. A Cambridge pure math student, posting as Acer, argued that Nielsen took apart the wrong groups, that the paper's real construction is a different, more intricate object, and the repository proves the disputed properties for that object directly. Strip the jargon, and the dispute is one question. Is the thing inside the formal proof the same thing the conjecture is about? Both sides cannot be right. So far, no specialist in this exact field has ruled. OpenAI has not responded, and none of the 10 results has seen peer review. The repository's own status line reads agent reviewed.
Zoom out, and this is the third jump in 4 months. In May, an OpenAI model disproved an 80-year-old conjecture about distances between points, and Fields medalist Timothy Gowers wrote he would have recommended the equivalent human paper to a top journal without hesitation, an endorsement that belongs to that May result, not to these 10. In July, mathematician Levent Alpog, working with Anthropic's Claude, found a small polynomial map that killed the 87-year-old Jacobian conjecture. Creator Ian Clark animated the fatal moment on his channel, 3 different inputs collapsing onto one output. Then August 1st brought 10 at once, with certificates.
Which leaves the price tag. $2,000 is real, but it is the narrowest possible accounting. Only the tokens spent finding the winning arguments, priced at OpenAI's own retail rates. It leaves out training Astra, the failed runs, and the humans who helped assemble the manuscript. And OpenAI published no ledger anyone can audit. Still, put it next to the problems themselves. Questions that outlasted entire careers. And a marginal bill? The price of a used laptop. So run the 3-level test the coverage keeps skipping. Level 1, claimed. 10 serious results, some full resolutions, some record-breaking bounds, and this time with receipts attached. Level 2, machine verified. Every certificate compiles, and anyone on Earth can rerun the check. Level 3, the right problem. 9 chapters unchallenged so far, 1 in open dispute, 0 peer-reviewed. A year ago, the question was whether AI could do research mathematics at all. That question is settled. The new one is harder. When a machine hands you a flawless proof, someone still has to check the question. For now, that someone is human.